Hello everyone, welcome back to Mr. Lee's Math Class Videos. I'm Mr. Lee. We're in the middle of 7.3 for either Math 2412 or 1316, which are pre-cal or trigonometry respectively. We've practiced using the cosine summation formulas in the first video, going from left side to right side on the formula chart, which again, you'll have your formula chart whenever you're doing this. It will be posted in Canvas, so you can look for it and print it off. But sometimes things are in the shape of the right side and you want to go back to the left. For example, if you notice this cosine A plus cosine B minus sine A sine B matches this exactly, you may be able to convert it to the left, because 67 and 23 degrees do not help us, but maybe if I combined them, it would. So cosine A, cosine B minus sine A sine B really is cosine A plus B, so our A and B respectively are here. So this is really the cosine of 67 degrees plus 23 degrees. And if we add those two together, this is actually all equal to the cosine of 90 degrees, really broken down into a unique way of 67 plus 23. But the cosine of 90 degrees is something we already know. This is actually 0, which means if you were to type that in the calculator, you would also get 0. D works similarly. It doesn't produce as nice an answer, but it does simplify what you would have to put in the calculator, so I'll let you practice that one before we again talk about the cofunctions. So you're going to get questions about the cofunctions on this homework, asking you to do things like write the following functions in terms of their cofunctions. As a reminder, a function and a cofunction match as if they're the exact same word. One of them has co in front of it, one of them doesn't. So sine and cosine are cofunctions. Secant and cosecant are cofunctions. Tangent and cotangent are cofunctions, which becomes a little tricky because we think about reciprocal functions. Reciprocals and cofunctions are not the same. To help you recall, for example, if you're doing the cosine of 37 degrees, its cofunction being sine, you always do 90 minus the measurement in question. So this is equal to the sine of 53 degrees. And even with radians, it's the same, but instead of 90 degrees, you'll use pi over 2. So 90 degrees or pi over 2, depending on if you're radians or not, degrees. Now, but sometimes you'll get ones in the second quadrant, and you might be asking yourself, does that work the same? And it does somewhat, as long as you understand the sign. For example, the secant of 142 degrees and 14 seconds, its cofunction is cosecant, and if you did 90 minus 142 degrees and 14 minutes, which is assuming that it's all negative, what would happen is what you could ask yourself. Now, technically speaking, if you subtracted that, it would be negative 52 degrees and 14 minutes. Now, the problem with that is it's not in the first quadrant, so we have to find ways of recognizing what happens between the quadrants. Now, sine and cosecant in this case are odd functions, which means the negative from the inside of the trig function can be pulled out. So this is equal to the negative cosecant of 52 degrees and 14 minutes, because that's really a 180-degree rotation. Not exactly, but it's been reflected across the 90, and the negative's been pulled out because these two are equal. So there are always ways that we can use the even-odd identities to show that these cofunctions work in more than just angles in the first quadrant. The same can be done over here with sine of 9 pi over 10. You just need to know if things are going to be negative or positive, respectively. In general, the secant of 142 degrees and 14 minutes will be equivalent to, another way to do this is to say that it's 1 over the cosine, or the cosine is reflected. We also know that secant in the second quadrant, if you think about it, is 180 minus 142 degrees and 14 minutes to get the first quadrant equivalent reference angle, which would be 37 degrees and 46 minutes. But since secant is negative, it would be the negative of the secant of this. And if you converted that and then converted that, you'd recognize that the secant and cosecant would produce that 52 degrees and 14 minutes, and the negative would stay there. So you have options for how you get there is the point. So I want you to try it for D as well. And then we can start to answer questions that are a little bit interesting in regarding to the cofunctions and see what happens. Use cofunction identities to find an angle in the first quadrant that makes the following statements true. Secant x equals the cosecant of 2 pi over 3. There are a few ways that you can do this because this is in the second quadrant. Your choices are saying if you use a cofunction, you know that the two angles are supposed to add up to 90. So if you did, well, equal to the secant of pi over 2 minus 2 pi over 3, you might find that this is actually the secant of 3 pi over 6 minus 4 pi over 6, which is negative pi over 6. The problem with that is this is actually not in the first quadrant, and they specifically say in the first quadrant. So cosine and secant are even, whereas the rest of them are odd. Now for odd functions, the negative can come out of the trig function, and the even, the negative just goes away because it's symmetric about 0. So this is actually equal to the secant of pi over 6 because it's even. So actually that means the answer for x needs to be just regular pi over 6 in order for it to be in the first quadrant. B is similar, but perhaps slightly less difficult. We've done ones like it before, so I'll leave B for you to do. Where do these sum and difference formulas come into play and help us? That's on the next page for finding things that are somewhat strategic. Say use identities and the sum and difference formulas to write each expression in terms of just a single function of theta. This is a common homework type problem. They want you to recognize this is cosine of A minus B. Even though A is just another variable, they want you to use the formula. This is cosine A, cosine B, plus sine A, sine B. And we'll see how this simplifies. In this case, A is just theta, cosine theta times the cosine of 270 degrees, plus the sine of theta times the sine of 270 degrees. What happens here is that the cosine of 270 is actually 0. Cosine of theta times 0 plus sine of theta times the sine of 270 is negative 1. And so you end up with 0 times anything is 0, and this is minus sine theta with the negative 1, which is really just negative sine theta. So the cosine of theta minus 270 is really negative sine theta. Using this sum and difference formula, you could be really, really cheeky and use the cofunctions, but I don't necessarily recommend it. It's much easier to use this. You can try it yourself on B, recognizing, remember, that cosine of A plus B equals the same exact thing, cosine A, cosine B, but with a minus sign in the middle. So that will be left for you to do, but I'll toss the formula up there. And we're not going to do both of them on 6. There's not enough room for it, so I wouldn't even recommend you do it. So we're going to cross out B because we're going to need all of the room for A. But we'll pick this up in the next video to show how it helps us extrapolate information based on two angles we have knowledge of. But that is all for this video.